So welcome you all again for this course, Machine Learning for All. I am Dr. Debraj Bhattacharjee, course instructor for this from Flame University, and this is our module 2 topic 2, regression problems. So previous topic we have discussed about the supervised machine learning. So this is one type of supervised machine learning problems that we will learn. In regression problem, so already I told this is nothing but you are trying to solve a problem where you are trying to predict some continuous value based on the available inputs. Some of the examples I already mentioned that let's say if you want to predict the value of a particular product or maybe your stock price every day, those kind of problem where actually continuous decision making is required, you should use regression type of problem. Now, if I give a formal definition of regression problem, then regression problem is a case where numerical relationship between some variable are established, basically between your independent variable and dependent variable. Independent variables are those which are nothing but the input for your model, and the particular variable you are predicting, that is your dependent variable, through some kind of supervised learning approach. In this case, definitely we are trying to find out or establish a relationship between these two set of variables, and further we are using that relationship to predict or estimate the value of your output or dependent value or output feature. Now you can see in this model a simple numerical representation y is equal to fx, and this is nothing but a pictorial representation or mathematical representation of the regression model, and y is your dependent variable and x is your independent variable, and x, f, that function is nothing but the relationship between that y and x. So this relationship is nothing but the regression, and through regression process you are trying to find out a particular relationship between y and x. There are several methods available in the regression, but in this course, because this is a basic course for understanding how machine learnings are working, we will be giving you demo for simple linear regression model and k nearest neighbor regression. Further, if we talk about the model evaluation, definitely when you develop some model based on the testing results, you have to just compare the two result, your predicted result or your estimated result and your ground truth or original available outcomes. Now, how to compare these two? So for that, in this course we will be using two matrices. One is R square, that generally known as coefficient of determination, and it is widely used in statistical models. This coefficient of determination tells how much variability of a dependent variable is explained by independent variable, or straight away you can say this is nothing but the measure of how much your output is deviated from your original observations. So basically we are trying to find out or trying to measure the difference between your original output and your predicted output from the model. Now in this picture I gave one simple expression for this R square calculation. So R square calculation, if you consider in a mathematical term, nothing but the ratio of sum of square predicted error and sum of square difference from mean observation. And here also the mathematical expression says the sum of yi hat minus y bar square divided by sum of yi minus y bar I square. So just in this expression you can say, if I know my original observation and the estimated observation, that is enough. From these two values or these two attributes, I can easily find out what is the performance of the model. And this R square value generally lies between 0 to 1, and definitely your desire is higher value for this R square. The more it is, the more the model is you can say that the more the model is accurate and it can predict pretty much good. So in standard you can consider that if your coefficient of determination value is more than 50, so you can consider it that your model accuracy is 50%, but that is not correct. Still you can consider it as an accuracy measure of how well your model is predicting. Now next performance measure metric is nothing but the root mean square error. Again, it is a very easy, again it depends on the or it is built on the same principle of deviation from your real observation and your predicted outcome. It is a measure of average deviation between actual observation and predicted outcome. So basically root mean square error is, in this expression you can see, root square sum yi minus yi hat square divided by n, where n is number of observation and y is observed output and y hat is nothing but the represents predicted output. So both of them are nothing but they actually tells you how much you are deviating from your original output, and this is a good measure for the model accuracy or how much the model is predicting. And in this case, in this root mean square, your desired the value should be lower. So why? The lower the value means the lower you have deviated from your observed output. So in the summary, I can say a regression type of problem deals with continuous value. In some cases, I can say that they also take some discrete value. Right now you just consider that regression models generally consider that continuous value. It tries to predict based on the previous observations, as it is a part of supervised learning. And in this kind of learning approach, we try to evaluate the model performance with the help of your predicted outcome and your observed outcome. So basically by measuring the deviation between your observed and your predicted value or estimated value, we try to estimate the entire performance of the model. So this kind of model definitely gonna help you to solve those kind of problem. Let's say you want to predict your next month bill or electricity bill. If you want to predict, okay, what may be the stock price next day, or maybe in your day-to-day life, what may be grade for next examination in the percentage term. And if you just use little bit creativity, you can use this model in different sectors. Hence, I again thank you all for listening and watching this video, and definitely you will be learning different topics, not only this regression model. In the next upcoming topic, we will be learning about classification model or classification problems, and then we will be understanding how these algorithms or these problems are solved with specific algorithm in the upcoming videos. Thank you.